Location-based services. Any application that uses location as part of the application is a location-based service. And a lot of people have preconceived ideas about what constitutes a location-based service, and they often envisage, oh, well, it's obviously something where you as a user will get some graphical display on your handset or something like that, and it'll give you directions or something. But location-based services are quite common. They're around a lot of the time, and they don't have to be of that nature. So if you look at a simple e-commerce website or something like that, and you can put in a postcode or a zip code, and it'll tell you what the delivery cost is going to be based on that postcode or zip code, well, that's a location-based service. That component of that e-commerce site is providing you a location-based service. So you can see that it didn't have to provide an automatic detection of your location. It didn't have to be anything particularly clever, but what it's done is modify the content and behaviour of the application based on location information. So that's the essential fundamental definition of it. Similarly, you don't have to be the person whose location as a user is of interest. So, for example, if we look at fleet and asset tracking services where somebody wants to know where their vehicles are on the road or something like that, they're not the target of the location. If there's automatic location detection concerned, they're the users of the location information. They're the ones using the service. So location services can take all sorts of forms. They may or may not involve automatic location determination, and they may or may not even be internet-based. If we look at the telephone network, people are used to dialing 1-800 numbers or 13 numbers, for example, 13 11 double whatever for a pizza delivery service. The telephone network, generally based on the calling number that you're calling from, works out what your nominal location is and will connect you to the pizza service franchise, which is whose catchment area you're falling in. So that's a case of the plain old telephony service providing a location-based service. It's not in the least bit graphical. Right? So that's the fundamental definition of a location-based service. It's just one where the application's behaviour or content that it provides is modified depending on the location of the target. So location-based services, having talked about the fact that they can take many forms, similarly will fall into quite a number of market segments. The all-important location-based service that's driven a lot of the investment in the industry, certainly over the last 6 to 10 years, has been emergency services. It's was never a terrific issue, but of course it was always still a location-based aspect of plain old telephony. When you dialed emergency services, that based on your calling line ID or your phone number, they could work out where you are. In many jurisdictions, for example the US one, where there are 6,000 public safety answering points, that information is important in terms of which public safety answering point to connect you to. And the display of that information then to the operator so they can dispatch emergency services to the right place is also an important aspect of that. So that's been a component of emergency services for some time. The automatic detection of your location became more challenging with cellular networks, and they have to work out where you are, not based on your mobile phone number, obviously. And then we go into voice over IP. Emergency services still have to be supported, but now we have a situation where the person who's providing the voice service and dealing with the emergency call doesn't actually provide you your connectivity, and they have an even greater challenge in terms of determining your location. So that's a fundamental market segment, if you like, for location-based services, and one which drives a terrific amount of investment across the industry. And that's really in the area of automatic location determination and the delivery of location information through networks. But once you have that sort of facility in networks, then the other market segments are clear too. So people who want to determine their own location, when they want to pull a location down to a device that they're using, for example, and it may be for things like driving directions or finding the nearest facility of some description, ATMs or restaurants or whatever. They're an important market segment. The ability to locate yourself and also locate friends to determine proximity and facilitate communications is another part of that kind of personal location service. And whilst they'll be important and certainly operators of networks will look for those as differentiators and value add that they can provide to increase the revenues from their networks. Commercial services are going to be very important as well, and I include in those things like the fleet and asset tracking type services, taxi services, things like that. And the value of those is that these sorts of industries have a track record already in implementing location-based services. In the past, it's had to be done as very much a vertical implementation. They've had to install and develop their own location determination technology, whether it was GPS receivers or whatever, and integrate that with some sort of communication backhaul, whether it's wireless data or switch circuit data or something like that, and then the application at the end. Whereas a network which includes within itself the fundamental ability to locate mobile devices in that network actually provides a horizontal infrastructure. And so you can expect those industries that already have a track record in investing in vertical solutions for location-based services to take advantage of the horizontal infrastructure that networks can now provide. So that's the emergency services, social services, the personal, commercial type services, and the business end type services. Government and Homeland Security, lawful intercept or other law enforcement services are also interested in location services, and they have their own requirements, and generally they're about tracking or identifying some party as part of some sort of investigation. And they have needs in terms of being able to do it relatively covertly, and they have requirements around being able to do it without necessarily having dependencies on the devices that the people are using. So whereas the commercial and personal service environment might be quite happy to be using GPS in the device because that's what they buy it in order to add value to the service that they're using. On a law enforcement side, you may actually be looking at location technologies to find people with legacy handsets or something like that don't have any innate location or locatability, because obviously the people you're interested in tracking may not be interested in facilitating your ability to do that. So yeah, there's a number of market segments, each with their own kind of personality. The fundamental nature of the service, which is a behaviour based on the location of something, is consistent across them all, and the differences in them really depend on what are the priorities of those different kinds of services. So yeah, services can be categorised as either push or pull. In fact, in the 3GPP specifications, in terms of the signalling scenarios within the network, they identify three different types of location request. And these are the types of location requests that when people talk about 3G cellular networks or whatever, they talk about the scenarios that need to be supported. And the first of those is a mobile terminated location request, and that would be a pull type location. So an application comes to the network, it says, here's an MSISDN or a phone number of a cellular phone. Please give me its location. It comes in through the Gateway Mobile Location Centre on the 3GPP network and asks for that location. The network then invokes the necessary signalling down to the mobile if necessary, hence mobile terminated, and determines the location of that device and passes that location information back up through the gateway to the application. So there we see an application that's pulling location. And that would typically be something like the fleet and asset tracking service or a friend finder service or something like that. So we are going into the network and pulling out the location. Mobile originated location request is another type. It also is in fact a pull location because it's then the mobile instead of some other application which is asking the network for its own location. So it's originating a location request to the network. It's going through the same signalling and may have further interaction with the mobile in order to find the location, but it returns it to the device. And then the third category is a network-initiated location request. And this is where the network itself, for whatever reason, triggers the determination of the location of the device, and then it will typically push that location information out to some interested application. And prime example of this is emergency services. So, for example, it's triggered by a mobile device dialing emergency services. The network then does a network-initiated location request, determines the location of the device. In conjunction with delivering the emergency call to the emergency application or the emergency call centre, it also pushes the location information associated with that device out to the network. Generally speaking, it's possible for just about any application to be recast from a push type application to a pull type application, in the sense that most applications have some basis upon which to be triggered. It's not usually just because of location. They'll be invoked for some reason, and that application that's been invoked can then, in conjunction with being invoked, go into a pull type location request as long as it has the identity of the device. Some examples of ones that you prefer a push type application for are proximity type services. So if somebody's going into the proximity of a commercial service, for example, a shopping mall or something like that, and you've got a application that wants to provide advertising coupons or discount coupons through SMS or something like that for it, well, it's quite good for those applications if they can be triggered based on the proximity of the user to the commercial service, and then push the location information up to the application. That saves, obviously, the application polling an arbitrary population of subscribers and waiting until they come into the proximity before they actually invoke themselves. So there's some network efficiencies associated with being able to push versus pull. So differences in location determination technologies. There are quite a lot of ways in which location can be determined. And here, essentially, we're talking about automatic location determination. There's always a way, if a user's involved in it, if they're the actual target of the location service, of just asking them what their location is. That's user-provided location. It's quite common. But if we leave that aside and talk about automatic location determination, there are many technologies. The technologies that tend to be adopted are very much driven on the environment and on circumstances, and in many cases what the legacy aspects of a network are. So if we look at cellular networks, you obviously have a network with a large population of user devices. If we talk about a GSM network or something like that, that's been around for a number of years, potentially millions of subscribers, and no technology in those devices which is native location determination technology. Nothing was done in the deployment of that network and those devices at the time in order to facilitate being able to determine the location of the devices. If you get an application that comes along that's got some imperative associated with it, like emergency services, the question then is, well, how am I going to determine location for users in that network if I'm in a situation where there's already a large legacy of devices and systems that don't support location? You see just about every aspect of this played out in the North American emergency services environment. If you look at the TDMA networks there, even before or perhaps without bothering to invest in standards-defined ways of supporting location determination in the network itself, let alone the devices, many carriers implemented overlay systems, and that is systems which essentially monitored the signalling in the network, pulled out the essential components that were useful for determining the identity of the device, the time of arrival of signals in the network, and farm those out to some other external server to determine location. They were using technologies that would work with legacy devices. In other words, they were looking at timing measurements that were measuring signals that were going to be in place anyway, signals that were necessary for the normal support of voice services, for the normal mobility functions in that cellular network. But you could still use the time of arrival of them at the base stations and other known points in the network in order to triangulate and determine location. So those sorts of systems are effective. They do have a downside in the sense that they're more expensive because you obviously have to invest in overlay equipment. You have to invest in devices that can listen for those types of signals and to timestamp them with a high degree of accuracy, usually off some GPS time-based measurement. And then you have to provide backhaul for the signalling, which is totally separate to your normal network signalling channels, in order to bring it back to some location where you perform the actual location calculations. On the other hand, they do facilitate the ability to add network location support to your network without actually having to invest in new network equipment and working perfectly with the legacy equipment you do have. If we look at the GSM networks, it actually modified their network elements, their core network and their access network elements to support the signalling that was defined by, say, 3GPP for taking network-based measurements. For example, give me the serving cell ID of this device, give me the timing advance measurements or the network measurement reports or the receive level reports. The native signalling is actually supported in there to get those kind of measurements. Then you're actually able to implement a location capability which is more integrated with the network and yet still has the ability to support legacy devices. So we're still going to ask the network for measurement of parameters that are still just normally associated with a mobile network. Timing advance and serving cell and all those sorts of things are just common parameters that you need to provide voice service anyway. And that will provide you a functional location capability with the cost of investing in upgrading your network to standards, but on the other hand, without the cost of providing new equipment and data backhaul that you'd have to do if you're doing an overlay type system. Now, all of those systems that rely on doing location determination of legacy devices all tend to have a fair degree of compromise in the sense of either accuracy or some other aspect. Accuracy is actually the main one, in the sense that the signals that you're measuring, the accuracy to which you can measure them, are really as good as you can get, given that those signals were never defined for the purposes of location determination. So we can look at something like taking timing advance measurements on a serving cell. You may typically, for 2/3 of the cases, statistically get below 1,000 metres to be able to locate someone. Quite a lot of good services can be based on that, and it's a fairly cheap way to get location capability. If you have a system which has overlay devices, location measurement units that are measuring those signals to a much higher degree of accuracy, for example with GPS timestamps, then you can probably get the accuracy down to below 500 metres or a few hundred metres. And that's better at the cost of more investment. If you want to get considerably higher accuracy, then you're looking at potentially going to modifications to the devices themselves. Now, the obvious compromises we've just discussed is that that's not going to work for your legacy population of devices. You may have to actually look at a period of time where you can phase in new devices based on normal handset churn, with the average lifetime of a handset being some number of years. But if you equip a device with something like GPS, then you can take advantage of the sort of accuracies that GPS provides. You can look at tens of metres of accuracy, certainly below 100 metre accuracy, generally speaking, and that's good location performance at the cost of the handset churn and the GPS devices in the handset. And you also have the ability of the network to be able to facilitate that GPS location determination by providing assistance data. Generally speaking, a device out of 24 satellites in a GPS constellation has to spend time trying to find which satellites are actually relevant to it, that is, which ones should be visible in the sky. It has to, once it does those, has to get a fix on them. It has to decode the pseudocode or code phase signals that the satellites send before it can do any of the triangulation to determine location. So the network, based on knowing the proximate location of a GPS device, can provide assistance data to it, and that assistance data can be used to tell the device exactly which satellites it should look for. That lets it dedicate its correlators and other resources that it has inside of it to just locking onto the signals from those satellites. That improves the time to fix, increases effectively the sensitivity of the device. And furthermore, you can actually just have the device take the raw measurements and pass those back to the network and have it do the triangulation. So the network can still do a number of things. Similar sorts of trade-off there in the sense of, well, that makes the network a bit more complicated compared to the device, but you do actually get better performance, speed to fix, potentially better yield and accuracy associated with the device. So all of these things have different compromises. And if you look at the situation in North America, as I said, it's basically got examples of almost every type of implementation. The reason being that different networks have different types of imperatives. We talked about those TDMA networks earlier, and they're the older networks in North America, ones where the capital works has pretty much run its course. They were looking at changing them out anyway. They weren't really going to invest in upgrading those networks extensively to be able to support anything, so they implemented overlay solutions for those. In the GSM networks, because there was a high degree of legacy, or a high number of legacy devices, and because the handset supply market is actually quite fragmented in terms of having lots of providers and therefore lots of potential providers you'd have to interoperate with for GPS or something like that, that market went down a network-based location determination based on taking measurements with location measurement units and doing the triangulation based on that. But if we look at the CDMA networks in the US, they went down a GPS in the handset-based solution. And one of the reasons for that is that Qualcomm, who are basically the founders of the CDMA technology, also effectively control the chipset market for CDMA devices. So they only had to provide a single chipset family with GPS capability, and that ended up by default in most devices. So we see different examples based on different imperatives and constraints that each of the network operators had in terms of what sort of location determination technology they selected. Bearing in mind that this is an environment we're talking about in order to meet FCC and the US requirements for emergency services, they all had, whatever solution they adopted, had to meet the constraints that were defined by the FCC. Those who chose network-based solutions, because it had the added benefit of supporting the full legacy user base, had lower accuracy requirements, so 300 metres for 95% to 95th percentile of calls, versus 150 metres accuracy for handset-based solutions like GPS for the 95th percentile of calls. So, they had those constraints as well, and you can bet that those FCC imposed constraints also had a bearing on what technology the users used. So in terms of who are the people who are doing location-based services, and something I mentioned earlier is that the definition of a location-based service is any application whose behaviour or content is at least affected by location information. So that's a very broad definition. And under that very broad definition, there are just very, very many location-based service providers. There is, however, a more populist view of location-based services, and that is really ones where we look at a specific market for mobility networks, cellular networks, and particularly those applications which explicitly require automatic location determination, and which probably quite overtly provide their content and behaviour based on location information. And in terms of the value chain of location services, if you like, there are players who work all the way from the physical layer of the network, network equipment vendors. They're the people who will be looking for things like implementing against standards, the functionality that has to exist in the network, implementing location determination technologies, whether it's time of arrival measurement systems, whether it's smart antennas for doing angle of arrival measurements, or whether it's GPS servers that can look at GPS reference networks to provide assistance data to GPS devices. They're the kind of they're providing the fundamental wherewithal in the network. And their market opportunity, if you like, is to sell that capability as part of their overall network offering to network operators who are cellular network operators and provide cellular services to their subscriber base. There are a number of third parties who are associated with that layer of the value chain. People who really specialise in GPS chips, for example, people who really specialise in providing antennas or algorithms for doing location determination, and they sell into those equipment vendors, generally speaking, as opposed to selling directly to the network operators themselves. Then there's the network operators, and they in some cases invest in location capabilities within their network on the basis of imperatives, for example, a social requirement to provide emergency services and the need to determine location associated with that. But in addition, they'll do it because they're looking at providing value add to their subscribers. And this may be for competitive reasons. In other words, in order to differentiate themselves from some other network provider, they may provide the ability to locate your friends, for example, if they're also subscribers to the same network through some web-based service that can actually locate them, or some SMS-based service that can actually locate them, or WAP-based service. Or they may do it purely because of the revenue opportunity that's associated with those services. In some cases, the applications in that former example are loss leaders in the sense that they'll do the investment in order just to remain competitive. But in other cases, they see them as genuine revenue opportunities. And possibly the most significant revenue opportunities are those ones that are associated with commercial services, the fleet and asset tracking services we talked about before, the corporate services in terms of monitoring staff who are in the field and the like, and also in order to provide those types of applications to governments and security services. So there are genuine revenue opportunities for those operators in terms of those services. Now, in the services themselves, if you now go beyond just the basic capability to determine location, to get a location, which is a latitude and longitude or some kind of civil street address or something like that, you actually have to build the application that's going to utilise that, the application which is going to change its behaviour or content based on that location information. And the network operators don't tend to build those themselves. In some cases they do, particularly if it's just an early start into providing location services to their subscriber base. But generally speaking, when they're looking for a broad mass market or even a highly specialised type location service, they will get that from another third party. So there are players out there, there's Webbraska and just many application developers who have grown up to a large extent just in the last 6 or 7 years. And they've grown up off the back of the emergency services requirement and the fact that this horizontal infrastructure is now present on networks, and recognising that in order to capitalise on that investment, the operators will want to deploy commercial services. And those application providers have products which range anywhere from the applications themselves, whether it's navigation services or whether it's the fleet type services themselves that they can sell to the operators to on-sell then to their end subscribers, to developers who sell middleware services, that is, environments upon which other applications that use location can be built on, which have the hooks and databases and other facilities that are more generic, but on top of which you can actually add location services. And so there's quite a market emerged in terms of that side. And those types of businesses kind of opposed to the network vendor type ones who are very much in the carrier grade type market and building robust network equipment. The application vendors are more characterised as a kind of web services developers, enterprise type equipment and that sort of thing that still an operator would put in their data centres, but is not necessarily strictly associated with their core network operation. And those different application areas actually also affect the characteristics of the types of products in terms of reliability, but also in terms of the operation and maintenance interfaces and things that they have versus the degree to which they use industry standard web services and application environments and things like that. An area for location services which is largely unexplored or unexploited to date are location services which operate within an enterprise type environment. And to some extent that's the reason for that is twofold. The most fundamental one is that there isn't a standard location determination capability that's provided in enterprise networks. But the other one is that the types of applications that enterprises may use may not be so obvious to people that it actually stimulates the market. An interesting kind of side effect of the awareness created out of cellular network location capabilities has been in the area of enterprise networks, and a number of businesses have grown up in terms of location determination technologies for example, Wi-Fi networks, 802.11 networks. So this is typically an enterprise type or even a residential type technology for providing wireless networking to IP devices. But companies such as Ekahau have come out with systems and algorithms that allow you to do RF fingerprinting within Wi-Fi networks and provide a server from which users can actually determine their location within an enterprise environment. And typically this will be a floor/office location or something like that. And to some extent that could have been a technology looking for an application, but the applications start to become apparent to people, particularly in an age now where telecommuting, flexible work environments, hot desking, things like that are becoming more common. The ability to be able to, for example, do something as simple as locate your colleague is not as straightforward as it once was. And so a enterprise system that, for example, allows you to locate a co-worker where the location of that co-worker may not be as static a piece of information as it once was, is actually quite a valuable tool for an enterprise. A location capability that exists in a campus type environment where people may have a much more wide-ranging capability in terms of where their location is, then the value of that can be even higher. So what we're seeing off the back of an awareness of location applications and technologies in carrier networks is something that's carrying over into enterprise networks as well. The internet is having a significant impact on many things. And one of the most significant impacts that the industry, the telecommunications industry generally is finding right now is that internet access or broadband internet access has created the opportunity to effectively displace plain old telephony services in terms of providing voice capability to people. That is the ability to place what we consider to be a conventional phone call from one person to another person, where effectively that phone call is carried over the internet. And all you need for that is some kind of broadband internet access. You don't need, in addition, a fixed analog phone line in order to initiate that call. So voice over IP, as that's characterised as being, is causing a shift in terms of the way networks are not only implemented, but have a very fundamental impact on the way voice services are provided and marketed. And the players that provide voice services now, unlike in the past with telephony services, are not the ones who necessarily provide you your network connectivity. With plain old telephony, you had to provide the network connectivity in order to provide the voice service. In fact, that's all that network was good for, so the two went together. Obviously with broadband internet access has many applications, and the ability to carry voice services is just one of them. And that discontinuity has created a situation where we have one group of players in a market or an industry who are selling broadband internet access, but they're not necessarily the same ones who are providing people with their voice services, their phone number, if you like. So we have players like Skype and Vonage. They are not internet access providers at all. This has an interesting implication for location services, and particularly when we look at emergency services. Emergency services had to deal with the fact that you could no longer rely on an association between somebody's phone number and their location some time back in cellular. So cellular already dealt with this. If you have a voice service which works on the internet, then you can go from one point of internet connection to another point of internet connection, your home DSL service, to a hotel that's got Wi-Fi access, to your workplace that has internet access as well. You can access your voice service from any of those locations. So obviously your phone number has no bearing on what your location is. And so just like cellular, voice over IP services have that characteristic of not being able to associate your phone number with your location. And cellular, to a large extent, solved a lot of those problems, so that's good. So if we look at an emergency network, for example, the one that's established in the US, or in North America generally, it already has interfaces within that emergency network that knows how to get location information pushed to it when a call is originated, that knows how to go out through the carrier's network and provide and get the location information if it wants to pull an update to that location, for example. These are already established. The cellular network capability for emergency services is quite mature and still being deployed in North America, but is mature and people understand how to do it. So to a large extent, those same interfaces and capabilities can be exploited in terms of servicing voice over IP calls. However, the interesting situation is related to that set of circumstances we discussed at the beginning, which is that the people who are providing you the voice service, who are actually processing the emergency call, are not the ones who are providing you the access to the network. So in a cellular situation where you could say, well, the person who's processing the emergency call, the cellular operator, also has to be responsible for knowing where you are and therefore choosing the right public safety answering point to route the call to, and has to be responsible for providing the correct location information for you to the public safety answering point. That situation doesn't exist with voice over IP. The one who's processing the call, whether they're Vonage or somebody else, doesn't actually know where you're accessing the network from. So you can't realistically apply the responsibility on them to determine the location. You can say they're responsible for appropriately handling the location information. You can say they must, based on location information, connect you to the right PSAP. They can say if they have the location information, they have to provide that to the public safety answering point. But they can't, due to the physics of the situation, be held responsible for accurately determining the location of the user. So this creates an interesting situation where the party which is responsible for providing emergency services for a voice service is not in any position to provide you the location or determine the location of the users. And in fact, the people who are in the position to provide the location of the users are the broadband internet providers who don't actually have anything to do with that voice service that you as a subscriber are interacting with. So we have an interesting situation where we, quite possibly of necessity, have to place a requirement on broadband access infrastructure providers, DSL providers and so forth, to provide an infrastructure for determining the location and providing the location of their users for an application which they notionally weren't actually providing in the first place. The FCC in the US has recognised this situation which has developed around voice over IP. There have been a number of tragic incidents which by their nature tend to be quite high profile and therefore result in a good deal of lobbying and pressure on the government to ensure that people subscribing to voice over IP services have the same access to a reliable emergency calling service that they do on a normal wireline or cellular system. They have resulted in the FCC being given a mandate to define some kind of regulation around that. The FCC have, at least in the first instance, said that the voice over IP providers are responsible for ensuring that an emergency service facility is available through them. So in other words, in the US, if you dial 911 for emergency services, that voice over IP provider, assuming they actually are a business that operates in the US, they are held responsible for ensuring that you actually get proper 911 treatment. That is to say, you will be connected to a public safety answering point, and to the extent that they're able to, it's connected to the correct public safety answering point. So that's a first phase of regulation that's been applied to voice over IP services that didn't exist before because they were treated as an information service like movie times or something like that, just an information service out on the internet. They're now being subject to a higher degree of regulation and because of these events. And to some extent it's based on the fact that those voice over IP operators sell their service on the basis that it's a reasonably transparent replacement for your existing telephony service. That is, they will put a device in your home that looks exactly like a telephone. You pick it up and you get dial tone and you make a phone call with it. And therefore it's considered beyond reasonableness for the average subscriber to be able to distinguish between one or other of those services. And in some of these tragic cases, in any case, it hasn't been the person who bought the service that's been trying to access emergency services, and they had no way of knowing whether they were going to get it or not. So this has led to that kind of pressure. The FCC have also, though, recognised that there needs to be a second phase of regulation, and this is going to be about ensuring that nomadic users, that is ones where users can actually take their phone service and access it from anywhere, so therefore there is no correspondence between their phone number and their location, are going to be serviced in much the same way that cellular callers can. And this now moots the arrival of regulation on potentially the access infrastructure providers to provide that facility to determine location, even if they aren't actually playing a part in the voice service itself. The National Emergency Number Association, which is an affiliate of public safety answering points and operators and other people who contribute to the overall emergency infrastructure in North America, the US and Canada, they have been working for the last 18 months defining an architecture which integrates with the existing cellular network interfaces in the emergency network that will support the ability of voice over IP calls to be delivered to the correct public safety answering point and to deliver the location information to the call taker. They have identified a location information server function that lives in the access network and from which location is provided to the calling device. That architecture that NENA, the National Emergency Number Association, defined doesn't say anything more about what that location server looks like, but there's obviously a emerging opportunity in industry now in terms of defining the technologies by which those broadband access networks can actually provide location information to the users. Now we talk about providing location determination capabilities in broadband internet access networks. Actually, we can talk about providing location capability as a native capability in IP networks generally. We're looking at possibly a replay of the sorts of things that happen in cellular networks. So we have this new imperative, we have new kinds of networks, but we probably have the same cycle of people identifying technologies for location determination down at the lower physical end of the network, moving up through standards that have to be defined so that network components can interoperate correctly to transport location information, and then what kind of applications can live on top of that network infrastructure that's created that now has a native location determination capability. So just as that grew up around cellular networks since the FCC mandate in 1996, we can see the same sort of thing repeating itself in IP networks generally. Just as with cellular networks, where many different types of location technology were identified, and whether they were overlay type ones or whether they were native to the network devices, whether they utilised specific aspects of the network itself in order to determine location, or whether they used something like GPS to do it, we can expect the same sorts of things to be considerations with respect to IP networks. So for example, we can look at a DSL network. How do you locate a user of a DSL network? So we have some arbitrary user connecting to DSL. They've come into your house and they're using your broadband network through your residential Wi-Fi network or something like that. How can the application out there know where you are? So the device that you're using that's connecting to it needs to get that location information somehow from the access network. So if it's a DSL network, the important thing is you're at a street address, you're at a residence, and that residence is at the end of a copper pair. There's some copper wires that are going from that house into an exchange building. They're terminating on a DSL access multiplexer, a DSLAM, and that DSLAM is converting your signals to an ATM or an Ethernet backhaul signalling, and that signalling is going through to some kind of a aggregator node or something in that DSL provider's network. And from there, it's going on some IP network out to the ISP. The ISP may or may not be the same person who's providing the DSL infrastructure. So somewhere in that network, you need to find the most optimal place to tap into the information that's being provided on that network. You need to make effectively measurements. You need to look at, for example, what's the ATM permanent virtual circuit that a particular IP address is using. If you can correlate those two pieces of information, you can relate that permanent virtual circuit back to the DSLAM termination, which correspondingly is associated with the copper pair that goes to that particular residential address. And therefore you have a mechanism by which you can determine a civil address location for a user on a DSL network. If we look at cable as an alternative, we now have a quite different situation where you have a cable which is going from house to house and is a shared medium. So there is no one end of that cable which identifies the location of the user. How does a device which is on a cable network actually get its location, or how is the location determined for one of those devices? There are a number of ways it can be done. They have different compromises. One way is to say, well, the cable modem has a unique identity as far as that cable network is concerned, and it has a subscriber record associated with it, and that subscriber record has an address associated with it. So as long as it's acceptable to the operator in terms of the constraints and expectations and requirements of location services generally, to say that an association with that modem is sufficient to provide an association with a location, then that gives you a direct civil address correspondence. One thing with modems, of course, is that they can be picked up and taken down the road or to another apartment in the same apartment block and be connected, and the network doesn't necessarily have any way of telling that. So it's not absolutely reliable, but may be considered a reasonable assumption, depending on the nature of the services. Alternatively, you may only be able to associate it with a cable head-end device, which is providing the head end of that cable, so therefore you can only provide a geographic area of coverage for that device. So much more like a cellular network, you're going to provide a latitude and longitude and some area of uncertainty associated with the location of that user. So you can see that cable networks will have different technical solutions for determining location compared to DSL networks. And the same will apply to WiMAX networks, and the same will apply to broadband over power line, or whatever location, whatever broadband technology, delivery technology is used, some specific technology or technique will be used to determine location. And the quality of the location information will also to some extent be affected by those technologies. What is really very important is that whatever technology underlies determining the location, what's very important is that the protocols used by the devices to request the location should be consistent across all those. So if you take your IP device, your laptop or your PDA, and you take it into a WiMAX network, and then you go to a DSL connection, or you go into your Ethernet switch network in your workplace, it shouldn't have to try to determine what kind of a network it's physically connected to when it comes to determining location. It shouldn't have one set of protocols for asking for location in that access network and a different set of protocols for asking for location information in the other access network. So what we're striving to do through the IETF and others is to ensure that there's a consistent and common protocol that IP devices can use for requesting location information, and that that same protocol can actually apply regardless of the access network. So that is to say that all the details and the magic that underlies that protocol in terms of how to ask for and get location, all the bits that underlie it as technologies for determining the location, are quite invisible to the device. The device, on the other hand, should be able to accept location information in the manifold forms it might occur in, whether that's a civil address, a latitude and longitude, or both, and whether that latitude and longitude has a large or a small uncertainty associated with it. That sort of thing needs to be handled at the application level, because no particular access technology can guarantee being able to provide universally accurate location information. So these are important considerations in the IP side, and ones that go a bit beyond cellular, because in the cellular networks you really were dealing with one kind of access technology for the device, and you weren't really concerned about how it would have to deal with any other kind of access. But in IP we already have a situation where IP has become the consistent and universal underlying protocol supported across many access technologies, and we have to make sure that location information can be dealt with in a uniform way across those access technologies. Looking forward then, there's a lot of work to be done. Despite the fact that location services technology is now reasonably mature in cellular networks, for example. Most cellular network element software loads being in their 4th or 5th generation or version when they've been supporting location services. Despite the fact that it's reasonably mature, there's still plenty of work to be done. And despite the fact that the mandate came out in 1996, so it's nearly 10 years ago in the US, there is still a significant proportion of cellular networks and public safety answering points that utilise location information that have to be updated and upgraded to be able to do that. So things take time. And the fundamental challenge is always going to be what's the imperative, whether it's a commercial/profit-based imperative or whether it's a regulatory type imperative that's going to drive the investment in the development of technologies and the deployment of it. The thing that's always going to make it more successful, or at least be able to happen more quickly, and the thing that's going to allow it to become more commodity more quickly is always going to be a good foundation of standards that allows equipment vendors to be able to manufacture things confident that it's going to be what users want because it's to a standard, and also allows the users to be confident that it's going to interoperate correctly with other vendors' equipment. So those are fundamental requirements to the successful development and deployment of these technologies, whether it's in the cellular world or now looking into the future in the general IP access area. So we need an appropriate imperative for investment, and we need to ensure that the development is done through some kind of standards framework that creates a common language for people as far as being able to implement things are concerned. The areas of research, as they were for cellular, are the same for IP networks generally. We have a fundamental area of research which is to do with how do you determine location. The mechanisms for determining location in a WiMAX network are going to be very much focused around RF type, radio frequency type environments, and the way you can do triangulation and timing measurements and things like that within them. All the opportunities that are coming out with new global positioning satellite systems. It's not just the old US-based GPS system now. We've got Galileo and GLONASS and the Japanese variant that can be used to augment location capabilities within devices themselves. So all those fundamental areas of research exist there, and they will be fertile areas for research going into the future. The next layer up needs to be the one which is concerned with the integration of those technologies into a common standards-based framework. So areas of development in terms of defining protocols, consistent protocols, security-based protocols, protocols for transporting location information, protocols for requesting location information. They need to be developed. And they need to address how you actually deal with different kinds of access network equipment as well. How does a managed layer 2 Ethernet switch talk these protocols compared to how does a DSL network speak these protocols, and which network elements do they appropriately belong in? Those are strong areas of research and development. The next area up is then looking at applications. How do you, once you've got location information out of a network, what sort of thing can you do with it? How do you effectively provide location information to users? What sort of scenarios is location information useful in? What's the most effective way to integrate it into an overall set of user dynamics that somebody interacts with? So application development is going to be another area. Security is a very significant area. One of the things that's associated with that discontinuity of it's no longer the voice service provider, for example, who is providing you the network, is that the third party who's receiving location information from the voice service provider in a voice over IP situation, just using that as an example, would like some basis for trusting the location information that's being provided to them. they may have some relationship with a voice service provider, and that may be a legal or a commercial relationship, but they may not have any relationship with the source of the location information. And so they'd like to be sure that the location information that they're getting is from some attributable source. And it's not just, for example, a user with potentially malicious intentions artificially generating a location that has no relationship to where they actually are. You can imagine the ability to call emergency services from another country if you just sent the signalling up appropriately to claim that you were in some proximity to a public safety answering point within that country. There are significant opportunities for mischief or more serious consequences. So how does that recipient of the location information have some trustability in the location information that's provided? And the mechanisms that can be put in place to provide that are going to involve technologies associated with encryption and public-private key mechanisms, and the digital signing of location information, so that the recipient of the location information can have a large degree of confidence that the party that determined that location is, for example, a recognised public internet carrier, a Telstra or the like, versus it was just something that could have been made up by anybody. So areas of research into providing security around location information is also another significant one. And then on top of that, there's a whole domain of study in terms of the social consequences of location information. A significant issue with location information generally is the privacy one. And so how should location information be treated? How should a network operator who can determine the location of any user at any time be bound and constrained in terms of how it deals with that location information, who it gives it with, how public it makes it? How bound or constrained should be the providers of application that use location information in terms of what they should do with it later on? And there are areas of ethics associated with this, and there are also areas of legal studies. Different jurisdictions have different privacy legislation and so forth, so how does that overlay on top of the technology, and indeed how should the technology reflect that back in terms of the capabilities that it provides in order to protect privacy? So there's lots of things going on. The extent to which that research can be funded, and the extent to which it can be fruitful and provide useful outcomes for people, will still be driven by that fundamental, well, what's the imperative for the investment? So now you've got these environments, you've got these technologies, you've got these standards for location services, location technologies, infrastructure. Somebody has to turn them into reality, and there has to be a process associated with that. So this is all on the assumption that the funding is in place, the imperatives are in place for the investment. The process of turning these sorts of things into reality is really around a disciplined approach to product development, and lots of it's just very prosaic. Quality systems define how you go through the appropriate stages of requirements definition, how you go through the appropriate stages of design, implementation, the full product verification cycles, how you go through the deployment and delivery of those systems, and how you go into a support cycle for those, and indeed how you take them out of service at end of life. You have to have rigorous processes and procedures around all of that. And one thing to bear in mind is that just as defining all these things in the long run ends up being a small part of that, actually writing the code or the software associated with these things ends up being a small part of all of that. And lots of it's around making sure that you follow the appropriate requirements definition up front and documenting things rigorously, ensuring that what you have defined is going to meet your customers' requirements before you invest in substantial development costs associated with it. And then ensuring that you go through the verification to ensure that what you've made is performing as you expected it to, but then subsequently validation, taking it to at least one customer, installing it in their network, and finding out that it really does meet their requirements, despite what you may have documented as their requirements. So all of that is a level of discipline and control that has to be established with any product development, regardless of software or hardware or both.